Today, on how it's made. Padlocks, a device that makes us feel more secure. Hair clippers, we have the buzz from the factory. Wooden shoes, clogging your feet, not your arteries. And synthetic leather, it's a matter of know-how and no cow. As long as there have been thieves, there's been a need for locks. Padlocks date back to Roman times and were likely first used as cargo locks to protect merchandise being transported. Thousands of years later, the padlock continues to keep burglars at bay. The modern padlock's strongest point is its laminated lock body. To make it, they stack 24 steel plates like these and then laminate them together. It's the same technology that's used to make doors for bank vaults. A punch press cuts and shapes pieces of steel into caps. They'll be riveted to the lock bodies. The rivets tumble down a feeder, while below, an operator places a lock body in a fixture and places a cap on it. A powerful press drives them into the assembly, securing the top cap to the lock body. At another station, cutters machine steel rods. They contour them so they'll fit into holes in the lock body, while lubricant keeps things cool. They load the rods into a form press. It bends the steel as easily as you could bend a pipe cleaner to make a U-shaped shackle. Then the shackles roll into a furnace for tempering, which will toughen them up. After a little more machining, the shackle is ready to be installed. This shackle will need to move up and down as the lock is opened and closed. And that's where these ball bearings come in. They install two in the lock cavity. These bearings will work with a cylinder extension to open and close the shackle. Lubricant gel aids the process. They use it to grease the inside of the lock, while at the same time pushing the ball bearings to either side of it. The cylinder extension goes between the ball bearings. Then they slide a protective casing and bumper over the lock. Now they assemble the locks. A machine loads copper-plated shells onto mandrels. Plugs, pins, and springs funnel into the lock assembly station. A device installs pins and springs in a lock shell. The shell slides onto a brass plug. This plug has a groove cut into it that matches a key. A carbide cutter notches the keys. There are tens of thousands of key profiles. This sorting station holds just a few. The keys and lock cylinders are all numbered accordingly. This worker matches them up, making sure there are two keys for each lock. She selects a padlock and pushes one of the lock cylinders into it. It's time to top it off with a retention plate. A machine press fits it to the bottom of the padlock. This secures the lock cylinder. They install a spring for the shackle, and the bottom cap goes on next. Then the entire assembly is riveted together. They try the key to make sure it matches. A computerized system opens and closes a randomly selected padlock thousands of times to make sure it's up to the job. Finally, they try to bust a lock on purpose. They drop weights to replicate the force of a hammer, and the padlock withstands the blow. This day's work is done, and it's time for the folks at the factory to lock up for the day. The invention of the electric hair clipper in 1919 was sheer progress. It was the first clipper with a motor in the actual unit, allowing the barber to cut hair at a very steady clip. Hairstyles change, but the electric clipper motors along, always on the cutting edge. Hair is definitely a growth industry, so these early electric hair clippers were an easy sell. These days, they make the casing for hair clippers out of heavy-duty plastic. An automated mold melts and shapes the plastic material into casing parts. A robot picks up brass contacts and places them in fixtures. Another robot then attaches a plastic switch to each contact. A blast of air sends the assembled piece to a bin. Here, a robot slides a plastic spool onto a mandrel, then anchors copper wire to it. They wind the wire around the spool more than 2,000 times to make part of the electric relay that will drive the blades. Pulleys keep the wire feed at an even tension. Next, robots work on the clipper's lower casing. One installs a blade slide for adjusting the blade, and another picks up a lever to engage the slide. The robot attaches the lever to the case and blade slide. And an automated screwdriver fastens everything together. Another robot then sends the clipper assembly on its way to have a metal arm placed inside. It'll move the cutting blade, and for that, it will need a couple of springs. They slide the switch assembly into position, and then screw the arm into place. They install a screw for adjusting the power setting. And now they fit the copper wire coil in the lower housing where it will drive that metal arm. To activate it with the flick of the switch, they run a power cord from the switch to the coil. Over at another station, a punch press stamps out blades for the clippers. The blades are toothless to start. They're not sharp enough yet to cut it in the barber shop. So after a good wash and heat treatment, they head over to another station to get some teeth. A worker pops a blade into a fixture to hold it steady, while a jagged, cylindrical cutter carves the teeth. Coolant keeps things from heating up and compromising the integrity of the steel as the cutter does its work. Each hair clipper has two blades, one with cutting teeth that moves over a larger stationary blade, which ensnares the hairs so they can be cut. Next, they print the company logo on the clipper's lid. And they attach the lid to the casing that holds the electrical components. They mount the blades on the head of the clipper for that double-edged cutting action. And finally, they tune each clipper for optimum performance by adjusting that power screw installed earlier. The clippers come in a kit. This one will be sold for consumer use, for those who want to try their hand at a little home grooming. Now these electric hair clippers are ready to make any bad hair day better. And with those toothy blades, they'll definitely make short work of any hair challenge. Call them the poor man's answer to the rubber boot. Centuries ago, farmers chipped out holes in wooden blocks to keep their feet dry. Now, people still wear wooden shoes, but for different reasons. And while they may look slightly more glamorous, how they're made remains as basic as the shoe itself. Most wooden shoes are made of poplar, easy to carve and generally free of knots. So it makes wearing clogs a splinterless experience. A worker feeds sticks of poplar into a bandsaw, careful to toss any pieces with defects. The blade slices the wood into blocks called blanks. The factory uses vinyl patterns like this one to create the shape of the shoe. There's a pattern for each size of every clog style. A worker locks one into a duplication machine called the shaper. Then right next to it, 2 blanks. This tracer moves over the shape of the pattern. The wheel on the left copies the tracer's movements exactly, its blades shaving the wood as it moves up and down. There's only one pattern loaded, yet the machine carves out a pair of shoes. That's because the blocks of wood spin in opposite directions while the blades chip away at them, essentially creating mirror image copies. That allows the machine to carve out both a right and left shoe simultaneously. Now for the instep. A worker positions the blanks onto what's called a dual-action boring machine. The center rod is called a tasker. Its rolling head follows the curves inside the pattern. The spoon bits on either side of it copy the tasker's movements, gradually carving out the inside of the shoes. Now they shift the angle so the spoon bits can get in deeper. They bore all the way to the front of the shoe. Then workers employ this very high-tech maneuver to remove the wood chips. They lay the shoes on racks to dry out the wood, then cut off the knobs at the toe with a bandsaw while inspecting for flaws that may have come out during the drying phase. A disc sander grinds down the knob on the heel and refines the shape of the toe. They work with a barrel sander to smooth out the opening, then switch to a balloon sander. The air-filled rubber sack inside flexes to the shape of the shoe as it sands. Now for the final step. An artist lays carbon paper on the shoe and a pattern on top of that. Then she traces the pattern. The carbon sheet transfers the design to the wood. Now she goes over the design with a wood burner. She changes tips and varies the temperature according to the size and depth of the lines and curves she burns. This design commemorates Holland, Michigan that is, in the United States. The artist now uses water-based paints to enhance the scene with color. She applies 3 coats of a water-based varnish to preserve the artwork and help keep the shoes clean. While most clog-wearing farmers opt for a plainer version, true clogaholics prefer a bit more pizzazz. But leave crafting them to the experts, because they leave big shoes to fill. Is it leather or is it pleather? It can be hard to spot the fake. Synthetic leather or pleather can look and feel very much like real cowhide. It may not be the genuine article, but its growing popularity means it's become a bit of a cash cow. Plenty of good-looking products are made from synthetic leather. To make synthetic leather, they pump a petroleum-based plasticizer into a mixing tub. They add an ultraviolet light stabilizer to provide protection from the sun's rays. And they pour in a flame retardant solution for a little fireproofing. As the mixer blends it together, they add powdered vinyl until the batch is about the consistency of pancake batter. Next, they pour different dyes into another tub, following a formula for a specific shade. They pipe the liquid vinyl into the tub with the coloring agents. Now, a big roll of paper with a leather-like texture to it unwinds into the coating machine. As tinted liquid vinyl flows into the machine, a mixing arm agitates the batch, and rollers below apply it to the paper. The vinyl-coated paper then travels through an oven, and the vinyl hardens, taking on the paper's texture. That first layer is only a thin one to establish the surface grain. A second batch of vinyl will contain a thickening agent. That's why they call it the foam. When applied to the first layer, it will give the fabric shape and structure. They pour the second vinyl concoction into the coating machine, and it rolls it on top of the first one. The double-layered vinyl then travels through another oven, and the heat activates the thickening agent, causing the second layer to expand. Once the expanded vinyl has hardened and adheres to the first layer, they roll fabric backing onto it. A machine then peels away the paper to reveal the textured first layer. Sometimes they print a pattern onto the vinyl to make it look burnished or two-toned. Then they mix a solution to build up its durability. Rollers apply it to the synthetic leather, finishing off this production run. But hold on, it's not quite ready to be shipped out. Samples from every run undergo a battery of tests. This machine rubs the fabric up to 3 million times to see how it wears. Then there's a stretch test. They fasten a weight to a secured strip of synthetic leather. The weight pulls it to double its length, but it doesn't tear, which means this fabric has a lot of give. This test is a trial by fire. They hold a piece of synthetic leather over a flame and it catches fire. To pass this test, the fabric must actually self-extinguish in 2 seconds. And it does, thanks to the flame retardants in the material. Next, they secure a piece in some framework and slide it into an oven to heat it to a more pliable state. A vacuum mold sucks the leather to its form, proving this fabric also has thermoplastic qualities. You can't do that with real leather. And because synthetic leather comes in many prints, textures, and colors, it seems like it's got everything covered.